Good morning, afternoon, and or evening, everybody. I think that should cover everyone, regardless of your time zone. If you're watching this video later, then it might be good night. If you're watching it late at night, I don't judge. Certainly, I've done enough of that myself. Welcome to PHP 7.4, the new hotness, presented by Platform SH. My name is Larry Garfield. I'm the Director of Developer Experience here at Platform SH. I'm also a member of the PHP Fig Core Committee, and I do implement PSR8 for those who get the joke. If you don't get the joke, ask me later in the Q&A, that's fine. So let's talk about PHP 7.4. That's why we're here today, I hope. If you're not here for PHP 7.4, then one of us is in the wrong chat or the wrong Zoom room. So 7.4 honestly is the biggest PHP release since 7.0. It is fantastic. It's a lot of new functionality, more than we've seen in a very long time. And what I'd like to do here is go through some of the new functionality and new features and new advantages of 7.4. And just for anyone who's not already on 7.4, give you a reason to get on 7.4, because it is the release that's made me most excited about PHP in years. So let's dive right in. Come on. So first thing to talk about, anonymous structs. This is a very common pattern in PHP, but I hope I don't need to go into too much detail about why this is actually a bad way to code. I mean, look at this pseudo object here describing an order, okay? Is cancel spelled right? Does cancel have one L or two? It depends. Are you in the US or in the UK? It's different. Is USR a typo? I don't know. Is the user supposed to be an ID or an object? I don't know. Are the SKUs, some of them are strings, some of them are numbers. Which one is right? I don't know. Are there other optional properties here? I don't know. Is that total in dollars, euros, pounds, yen? I don't know. This tells you nothing about your code. What's better, and what I hope you're already doing, is using name structs, that is, actual objects with properties on them. We now know all of the possible values of order. We now know we're using the 2L version of cancel, which is actually the UK version, but it's also valid in the US. English is weird. This is a lot better. It's not 100% better, but it's like 80% better, because we still don't know about a lot of these properties. But now we do. As of 7.4, you can put types on object properties. This is easily the headline feature for PHP 7.4. We now know, oh, the order ID is a string. The total is a money object rather than just a float, which is a good thing. We know that the user is spelled USER, and it's a user object, not a user ID. And now the code syntax itself will tell us what we're doing wrong if we try to put an ID instead of a full user object into that user property. Just by typing the properties themselves, which is now easy to do, we can make the code, make the compiler, make the engine do our debugging for us and force us to not do things wrong long before it gets to production. Type properties are valid for any type except for callable and void. Void, because it doesn't really make sense. If you have a property typed void, then it doesn't actually, you can't assign anything to it, so it doesn't make sense. And callable, because there's actually some engine weirdness around it, and a property that is explicitly typed callable does some weird things around visibility. I never quite figured out what all the details are. They're quite complicated, but anything besides void and callable, you can type a property. You can still assign a callable to a property, you just can't type it as such. They are enforced on set. That means when you set a property, there's a little check in the engine, hey, is this variable the right type? And that means there's a very slight performance hit when you're on write, but in practice, you're going to be reading a variable or a property far more often than writing to it. So, the odds of you noticing are minimal. They can be nullable. So in this case, you can explicitly set user to null. Without that, null is not a valid value, just like in parameters and return types. They will obey strict and weak typing mode. So if you're in a file that is in weak mode and you try to assign a numeric string 5 to a property that wants an int, it'll work. If you're in strict mode, then you'll get a type error because a string is not an int, just like properties and return values. The type cannot change in inheritance though, because we'll get to the reasons why a little later. It's called covariance and contravariance. Basically, the read and write need to behave differently from each other. And so you can't widen the type without breaking one. You can't tighten the type without breaking the other. So the type is the type. Inheritance cannot change that. Fundamentally, if you are one of the people who feel that good code is self-documenting, and I agree, then you want to be using typed properties absolutely everywhere, because this is documentation built into the code that cannot go out of date. If it goes out of date, your tests will fail. This is a good thing. You can set default values for properties just as before, as long as they are a valid value for that type, including you can set them to null if it is a nullable type on that property. If it's not nullable, you can't. However, if you do not set a value, they do not get set to null. Lines 14 and 15 here, K and L are not null. They're a new type of value called uninitialized. Don't be scared, it's not quite as weird as JavaScript. Uninitialized is a special state that you cannot read from. If you try to read from it, you will get a type error thrown. So in this case, we create a new product object. Size is uninitialized. It's an uninitialized string. And you try to read from it, it just blows up. You want this because this forces you clearly did something wrong to get to this state. Therefore, go back and fix the thing you did wrong. You want that. You should either set your initial values in the definition or in the constructor. Generally, I would advise don't allow any properties to go past the constructor in an uninitialized state. If you have a property that legitimately could be empty, having it just not have a value is a valid part of your domain model, well, that's what null is for. Go ahead and make it nullable and then set it to null. That said, if you have a property that could be null, question your data model, there's a good chance your data model is wrong and you need to refactor it so that null is not possible. Null is always a code smell. So when should you use typed properties in PHP? Always. I'll go ahead and say it. As of PHP 7.4, every class, every property should be typed unless it's a callable. The advantages are enormous. The disadvantages are, I don't think there are any. So yeah, just use them always. It's fantastic. Number 2, a bit smaller this time, bit of a just convenience feature. Seen code like this before. Take a value. If it's already set, cool, use it as is. If not, give it a default. This is kind of boring and repetitive. So we have short ternary. Cool, let's remove some duplication. Problem though, what if username doesn't actually exist? What if the variable isn't set? Well, then we get a notice, and that's less fun. In this example, it's kind of obvious. You wouldn't end up in this case, but if the variable you're accessing is a key of an associative array, perhaps, then you may run into problems here. So you end up with some ugly nonsense like this. And this is terrible. So PHP 7.0 gave us the null coalesce operator, also known as the what operator, double question mark, which reads as if the variable on the left, or the expression on the left, is set and not null, use it. Otherwise, go to the next one. So this reads as if username is set and not null, return username. Otherwise, if user arrow username is set and the return value is not null, use it. Otherwise, use the string anonymous. But okay, this is an improvement, but there's still a duplication at the beginning with username, which again, depending on the code you're dealing with, could be a lot more verbose than that. So 7.4 comes along and adds the null coalesce assign operator, question mark equals, which is exactly the same as the previous line. If username is already set and not null, just leave it as is and don't do anything else. We don't even bother calling the other parameters. If it is unset or null, then go ahead and call the others. Note, these check for setness, not truthiness. If username is an empty string or false or 0, that's fine. That will get used, that'll pass, and it will not get changed because that still passes the setness check. When should you use null coalesce assign? I've mostly found it useful when setting default values for an object parameter. Say you have a parameter to a function that defaults to null, and then you can say, all right, just if it's set to null when passed in, then here's a default void. Otherwise, just use it as is. And generally, just it's an option. If it makes your code prettier and easier to read and more compact, use it. If it doesn't, then don't. Next up, my personal favorite, honestly. Anonymous functions. I like anonymous functions. Anonymous functions are cool. There's a lot you can do with them. You can make some really nice, elegant algorithms with them, but their syntax is kind of verbose and ugly. I'll be honest. See on lines 5 through 7 here, we have function, parameter, use, then the value, and then we have to close the function definition on line 7 with the curly brace. You have to manually import the scope, just like in C++ with the use statements. They're just kind of clunky, but not anymore. 7.4 introduces short lambdas, also known as arrow functions, also known as a more compact syntax for doing the exact same thing. Lambda being the fancy computer science term for function. Short function, short lambda, same thing. In this case, if we look here on line 7, fn, shorter keyword, parameter, double arrow, and then an expression. In this case, it's user get field. That's an entire function. That is this slide is exactly the same as the previous slide in terms of what it ends up meaning, logically what it does, but it is half as much code to write. And that's good. It also takes care of imports automatically. This is good. So short lambdas look like this. You have fn, optional parameters, arrow, and expression. That function, when passed parameters, will evaluate that expression and return it. You don't need a return keyword. It'll support types or not. So if you want to, as on line 5, specify types, just like in any other function, you can. If you don't need to in your use case, you don't have to. It's legal both ways. You only have a single expression on the right side, however, and that expression value is what gets returned. This is a good thing. It encourages you to use it for function as value. And that's a good thing. It auto captures by value. So if you have an expression that uses a variable that's in the scope, you don't need an extra use keyword. It just kind of works. Take note, it does capture by value, not by reference. In practice, that doesn't matter 99% of the time. And that other 1%, you pretty much always want it by value anyway. If you really do need to capture something by reference, use the long version. But really, that's generally an unwise thing to do anyway. And you can think of it as a function literal unto itself. You're defining a function as though it were a value like any other because it is. This is a mindset shift. It doesn't let you do anything you couldn't do before. It lets you do it in a much more compact and graceful and easy to read way. And that lets you conceptualize function as value much more easily. This is huge for functional programming. I'm going to assume you're all groaning at the pun there because I can't hear you. For example, it lets you do partial application super trivially. What does that mean? Let's say we've got a function. It takes multiple parameters. Cool. we can now close over one of those parameters in a single line. Volume with x here is now a new function that takes two floats and returns a float, just like volume, and calls volume. But the x value here comes from line 1. It's hard-coded now to 5. And y and z come from the parameters. We can do it a second time and say volume with x, y. In this case, we have a function that takes just z, and it's going to call the function volume with x with a hard-coded value for y of 4, and then whatever z is passed in. So we can just build up functions piecemeal like this in a trivial amount of code. And you can even do it in one pass. In this case, we have a function volume for length. This is a function, you can call it like anything else. It takes one parameter, that's going to be the y value, and that just is capturing over 5 and 8 for the x and z. Plenty more complex examples, but you see how simple it is now to take any function and reduce it to a single parameter function. If you want to do that with objects, you can. It's just a lot more verbose. This does the same thing. Volumizer for length gives us the same capability as that previous slide, but it works only for y, and it takes 15 lines of code instead of 1. Okay, 14 lines of code instead of 1. I'll take the 1 line of code, thank you very much. Especially since that's then native language syntax, and I can use it for any parameter and any function I want to wrap over. I mentioned before, this way you can make any function single parameter. If you make a function single parameter, you can do something really cool with it, because you can then take the output of one function and pipe it directly into the input of another function. You can just chain them together with a simple function called compose. This is not built in, it's something you can write yourself, but it is trivially simple. You have a compose, which takes in an array of functions and returns a new function that will, using array reduce, iterate over that, take a single parameter and then iterate over that list of functions, passing the result from one into the next. Which means we can now do code like line 7 to 12 here, where we pass it to compose an anonymous function that is closing over get shopping list. The return value of that will get passed to this anonymous function that is closing over most expensive item. The return value of that gets passed to this function that's closing over get promotions, which itself is closing over the holiday variable. And now we have a function that we can pass a user and get back the promotions we should show to that user. And it's 6 lines of code. This makes building and assembling tiny components super easy. This makes, break a problem down to tiny little pieces and then glue them back together extremely easy. And each of those little pieces is then extremely testable. Type properties are the headline feature of PHP 7.4. I think in the long run, this is going to be the real game changer. Short lambdas, simply because of what it makes easy and convenient to do. When should you use them? Anytime you'd have a map call or a filter or a usort or a place where you would just stick a function literal in there, go ahead and use it. Anytime you want to call function parameters out of order, for whatever reason, doesn't matter, this is your go-to tool. You can just take that function, wrap it into a closure with a short lambda in one line, and you've just essentially written an adapter for a function in one line. And anytime you really want to be thinking about your code in terms of functions rather than big complex data structures and services and so forth. Honestly, I think this is such a big deal that I have a book coming out on this topic called Thinking Functionally in PHP. Follow me on Twitter. I'll be tweeting the link for that. It should be coming out in the next few weeks from LeanPub. So stay tuned for that in commercial. What else? Yes, there is more cool stuff beyond just those. For example, we now have full method covariance and contravariance. Whatever that means. Okay, what does that mean? Well, according to Wikipedia, covariance means preserving the ordering of types from more specific to more generic, and contravariance means preserving the order of types from more general to more specific. And I still don't know what that means. What it actually means, subclasses actually work in inheritance now. What do we mean by that? Let's look at some examples. Prior to PHP 7.2, if we have a class favorite finder and a class user favorite that extends it, and we've got these types, you can't change them. Even though user favorite we know is going to be more specific than favorite finder is, we cannot change those type hints. The language just didn't allow it. 7.2 introduced limited covariance and contravariance, which means we can add a return type and remove a parameter type. In this case, user favorite finder returns a something. User favorite we know is going to return a t-shirt, so we can type it as t-shirt because t-shirt is a special case of a something. Similarly, favorite finder takes an admin object. User favorite wants a user, but a parameter of a something is a broader case than admin. So it's permitting the same thing as the parent and then some. Just like the return value is returning a subset of the parent, which is still legal. So Liskov substitution principle still applies, and we're good. This is nice. 7.4 lets us actually control the types fully. So we can say favorite finder takes an admin, returns a product. User favorite takes a broader case for a parameter and a narrower case for the return, and everything still works. To be honest, I have not run into a need for this all that often. Sometimes I do, usually not. When I do, it's usually return self. The main takeaway here is return self now actually works. This is great for value objects. If you try to use this code in older versions of PHP, you get this. Declaration of special list add must be compatible with a list. Why? Because self on line 6 means special list, self on line 2 means a list, and you can't do that. As of 7.4, you can do that, and this will do what you logically expect it to do. This is great for fluent interfaces, for evolvable value objects, and other cases where you want to do really good data modeling. If you have an interface that's returning object of same type, this is going to be great. But wait, PHP 8 has already been confirmed to have a return static, which is even better, and usually what you actually want. So we're already seeing into the future it's going to get even better. When should you use this? If you got value objects, go for it. Basically, the thing you sometimes wanted to do but couldn't, now you can. Don't go out of your way to find a reason to use it, but it's one more thing that just gets out of your way now when doing data modeling. Number 5, let's talk about serialization. Wrong serial. What do we mean? We mean turning objects into strings. PHP has a number of different ways of doing that, and it's kind of tricky when you want to do one versus another. The old way, that's been around since somewhere in PHP 4 or maybe older, probably just PHP 4, is the sleep and wake up methods. In this case, when you call serialize on an object of type user, then rather than taking all of the properties and just throwing them into one big list, which is what will happen by default, it instead calls the sleep magic method. And what you return is an array of the property names that should be serialized, and those that shouldn't just get skipped. So in this case, we serialize a user down to the bottom, and the end result is the string O for user to blah, 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 blah. But you'll notice there's no date time in there at all. And then when you deserialize a object, that it deserializes a string back into an object, that list of properties gets populated, and then the wake up method gets called, which is kind of like a bonus constructor in a sense. It doesn't get any parameters. It just lets you repopulate values in the object if you need them. which is kind of a gross way of doing it because then you have to call out to globals and those are always wrong. Now, this does have a number of advantages. Inheritance actually works because you can just call your parent sleep method and get back its list of properties. If you have object references, if you have that you're serializing, those will still work properly because the serializer engine is the one doing all the hard work. And so it can tell, oh, you've got 15 objects in here and some of them cross-reference each other and you've got circular references and an object refers to the same object twice. So it'll take care of compacting all of that. On the downside, you can only serialize existing properties, which is not always good, especially if your serialized form is not almost a one-to-one map of your object version. You have basically no control over deserialization at all. So 5.1 introduced the serializable interface, which is kind of a funny name, borrowed from Java, because all objects are serializable. In this case, we have two methods on the interface, serialize and unserialize. In this case, serialize returns the full string. You can serialize your object however you want, return any string you want, and that is the stringified version of your object. Unserialize, that same string gets passed to it and you can unpack it however you feel like. Note in this case that the output, the serialized version, is a different structure. It's C colon blah, 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 blah. And then the internal structure of that string is a bit different. The slides will be available later if you want to actually dig into the string itself. For now, don't worry. On the plus side, this does give you a lot more flexibility in the representation. That's about it. On the downside, this doesn't handle circular references at all, because each object is serializing itself with no understanding of any other objects it may be referencing. It also means inheritance doesn't work. If you want to serialize your parent object, if you have an object you want to leverage its parent, you're going to get back a string, not list of properties. You're getting back a string only. How can you put that into your own serialized version? It may or may not work. It also means that, therefore, the serialized value is not in a standard form. In the example on the last slide, we just called the serialized function on an array. But you could return a JSON string, you could return a tab-separated string, and it'll work. It just is not actually comprehensible to anyone except your own object. So you can't really guarantee that anything is what you think it's going to be. And therefore, the serializer can do no optimizations. You can have redundant data. It's just not good, for the best way to put it. So 7.4, we now get the serialize and unserialized magic methods that give us the best of both worlds. In this case, when you serialize an object, the serialize magic method gets called, in which you return an array that will then get serialized. What's in that array? Up to you. When you unserialize a string to an object, that array is what gets passed to unserialize, and you can then unpack that array however you want. In this case, they do kind of map to existing properties. There's no requirement that they do so. Note also at the bottom that this is then in the exact same format, the exact same syntax of serialized string as sleep and wake up. So what does it do well? Inheritance works again, because you can call your parent, get back an array, and then add things to that array. Because the serializer is doing the hard work, object references can still be retained, the graph can be retained. You get complete flexibility about what the serialized form looks like, but you're still pushing all the hard work off onto the serializer. And it's also backward compatible with sleep and wake up, because it uses the exact same formats for the serialized string as sleep does. Also, it's kind of a normalized operation. If you've used serialization libraries in user space, like Symfony serializer or JMS serializer or things like that, they usually have a two-phase approach. One where you take an object and normalize it to a standard form, which almost always means gigantic array, and then a stringifying phase where you take that giant array and turn it into JSON, XML, YAML, whatever, and then back around for the other way around. now we have essentially a normalize option built into the language, and any object can declare its own normalized version, and it just works. Does that mean that we're not going to need normalize libraries anymore? I don't know. Maybe. I haven't figured it out yet. Calling the magic method yourself manually may not be entirely kosher. We'll see what happens. On the downside, I don't know. I haven't found any yet. Seems to work. Now, if you implement multiple serialization mechanisms, serialize, the magic method, takes priority. That will get used first if you try to serialize an object. If that is not defined, then serializable, the interface gets checked for next. Then sleep, then the default behavior of just take the properties and squish them together. When you're unserializing, and the string you're unserializing begins with the O colon, it knows, it's in that format. Use unserialize, failing that, use wake up, failing that, go with the default. If it begins with C, the engine knows, that's using the alternate version for serializable, and I'll use that. What this means is you can implement multiple generations of serialization in the same object, so you're compatible with multiple different PHP versions. Cool. When should you use this? Basically, if you want to serialize things anymore, or if you need a cheap normalized form, this would be the way to do it. I'm going to go ahead and say this is how you should be doing it these days. Number 6, nice easy one. How do you combine these two arrays in PHP? You have 1, 2, 3, and 4, 5, 6. How do I get 1, 2, 3, 4, 5, 6 all in one big array? Well, your first instinct might be to just add them together. But no, that's how you do associative arrays. If you do it on numeric arrays, add only replaces missing keys. So this takes an array that has keys 0, 1, 2, an array that has keys 0, 1, 2, and says, oh, there's no keys in the second array that are not in the first, so I'm not going to do anything. What you got to do instead for a numeric array is array merge, which it gets the job done, but I always forget to use it, honestly. It's kind of fugly, and it's like, shouldn't array concatenation be a built-in operation? Why does it need to be a function? Well, now it's a built-in operation with the new array spread operator, which is an ellipsis or splat. Splat is the better name for it. That's what I'm going to call it. Deal. There are now 3 different splat operators in here in PHP. All of them are in this function. The first is on line 1 in the function definition, where it reads as, and any remaining parameters to this function all get shoved into an array called users. And you can even type it to be, they all must be of type user. The second, line 4, so the first one basically replaces funcget_args. Never use funcget_args anymore. That's been true since 5.6. The second is line 4, which is the spreading splat operator for call, where that reads as, take the array params and spread it out or splat it out on the floor to spread it out into the parameters to this other function. Basically, you never need to use call user func array again. This is faster, in fact, so never use those. And the new one on line 3 reads as parameters equals, or params equals an array A, B, and then all of the values out of users. Much like line 4, it's just kind of spread them out. And now you don't need array merge anymore. Now this only works for numeric arrays. It doesn't work for indexed arrays, but it lets you embed arrays inside arrays very simply with just straight up language syntax. And I think that's just kind of amazing. When should this be used? If you would have used array merge in the past, do this instead. Or if you have a case where you need to embed one sequential array inside of another, this is what you use. Again, it doesn't work for associative arrays yet. It might get enhanced in the future for that, remains to be seen, but it's already a nice addition. Next up, an easy one. What number is that? Too late. I can't keep track of how many zeros that is. Now I can. These will compile identically, but you can now put underscores into numeric literals to make them easier to read. They mean absolutely nothing to the actual code. They just mean it's easier to read. So I can tell where the groups of zeros are, and I can tell that this number is 10 trillion. And it works for any numeric value in any format. It works in floats, integers, hex values, binary, even octal. All they do is help readability. But I think they do a good job of that, especially things like hex, where you're going to have values in chunks of 4 anyway. So you put an underscore at each 4 to make it easier to read. The underscore can go between any 2 digits, not at the beginning, not at the end. You can't have 2 underscores together, but any 2 digits within that set. So if you wanted to do like the binary version, have it every 2 instead, you can do that. It's whatever makes your code more readable. That's it. When should you use this? When you have some really big literal or binary or hex. I think it's most useful in binary and hex, quite frankly. Now let's get to some really fun pieces. This is the advanced stuff. What is the slowest avoidable part of a large app? What part of a large application is just wasted CPU for the most part? Autoloading. You spend a lot of time on your autoloader in large applications that it'd be really nice to not, because that's just wasted time. To understand why, we have to understand how the PHP op cache works. Typically, when you require a file, then PHP first checks, all right, is the code for that file in my op cache? If no, it reads the file from disk, which is very slow, compiles it from PHP source code, a giant string, into opcodes that can actually run on the Zen VM, which is slow, and then caches that. Then it resolves the types and dependencies. That means checks for parent classes, makes sure that everything's linked correctly, that the types match, the covariance and contravariance are good, and all that kind of stuff. And then loads that into process memory so that every individual PHP process has its own copy of that code. And then it executes it. Then the second time it loads, it skips over those first 2 steps, but it still has to go through and resolve the dependencies and load it into process memory. And that takes time. 7.4 introduced a new feature called preloading, where when the server starts up initially, you run a script once that you can specify in your ini file that will read a single file from disk, which itself can then compile source to opcodes, go ahead and resolve the types and dependencies and load all of that into shared memory up front. And I said shared memory, not process memory. That means this all happens before PHP FPM forks to separate processes. So all of that memory gets used once, not once per process, but once period. And then when you're in the application, you want to use a given class. Oh, it's already loaded. You'd never trigger the autoloader. You never have to compile anything. The types and dependencies are already resolved. You skip those 2 red steps every single request. You never touch the disk. There's no autoload, nothing. This can be a huge performance improvement, potentially, because you're eliminating just dead wasted time. On the flip side, anytime you change one of those files, you have to restart PHP. No way around that. So don't do this in development, but you can do it on production. But it's not always a win. Sometimes, if you have a class that's not used very often, it may not actually be as beneficial as you think. How do we do it? Call opcache preload and set that to some script. I'm going to call it a preload script right now. And then preload script, in this case, I'm going to iterate over every .php file in the vendor directory and call opcache compile file on it, which is, hey, load this file, compile it, shove it into shared memory once. Is this the best strategy? Maybe, maybe not. Technically, as written here, I think it probably would pull in test files as well, which you rarely want, so don't use this code as is. You may want to load more than this, you may want to load less. It does increase the size of your shared memory usage, though. So whether it's a good trade-off or not, is going to vary by your application. You're going to have to do your own benchmarks, but it's there. In practice, I suspect most projects are just going to start auto-loading everything, which is not the worst strategy. It may not be optimal, but it's not the worst strategy, especially since it does give you a decent CPU benefit. So when should you use preloading? When your benchmarks tell you. If you have something that's not easy to autoload, like functions, I'd say go ahead and preload those, just period. In practice, I'm probably just going to start autoloading most of the code unless I have benchmarks that tell me otherwise. But again, it's going to vary application to application. It's on you to decide what fits your application best. One more big feature. And this one is kind of tricky. It's kind of edge casey. And beware, here be dragons. It's an Australian water dragon. Isn't he cute? I just want to, scratch under his chin. Anyway, I'm talking, of course, of the new Foreign Function Interface, or FFI. What does that do? FFI allows you to expose C ABI code to PHP. Gobbledygook. That means you can take a C library or code that's written to look like a compiled C library and access it in PHP without writing an extension. It works with any language that can compile to something that looks like C when it's compiled version. Mostly that means C, C++, and Rust. Technically, you can do things like Go or Java, but garbage collected languages in FFI do weird things, so you generally don't want to try and do those. There's bizarreness that happens. And the API for it, unfortunately, is kind of clunky, frankly, but it does get the job done. But also beware, there's some security considerations as well, because loading random C code is not always secure. Who'd have thunk? So let's see this in action. We're going to have a very simple piece of code here. This is C code. In C, you have to define a header file, which is kind of like an interface for a file. And then .c file is where the code lives. So in this case, we're going to define a struct called point, which has two properties, x and y. And we're going to define a function called distance, which takes 2 points and returns the distance between them. Double is the same as float, floating point number, double precision, floating point number, whatever. Then points.c, we're just going to use standard Pythagorean theorem, don't worry about the math, and return a floating point number. You take that C file and you compile it into a .so file, which is a shared object. I'm not going to cover that. I have a blog post that covers that in more detail, link later. But you're going to take this code and produce a shared object file. That's something you can dynamically link, dynamically load at runtime. Now in PHP, we're also going to define a point class that takes 2 properties, x and y. You don't have to do it this way, but I find it much easier to build an API layer around the FFI bits. So we have a value object we can transfer from C speak to PHP speak and then use appropriately. And then we're going to require that classes file manually because it's old school. And then we're going to call FFI CDEF, which is not an alphabet lesson gone bad. It stands for C definition. And it says, create a new FFI object in PHP memory using this header definition, which we're going to just steal points.h for, pointing to this points.so file that we compiled. And now $FFI is an object that lets us bridge into that C library. We don't have to write any actual C code to do that. And now we can create a couple of points in PHP, that's normal. Then lines 8 and 9, we're going to create a new C-style struct point object. And then just do a straight property assign across from one object to another. And then we can call the distance function in that points.so library as a method on FFI, pass it those 2 properties, those 2 parameters, and get back a float, which we can then print. In practice, bear in mind, the header parser that CDEF uses is truly awful and doesn't handle about 2/3 of what a C header file can do syntax-wise, which means you're probably going to have to write the header file yourself manually, even if you're pulling in an existing library that has a header file. You may want to do that anyway if you only want to expose certain fragments of a library, but still it's something you need to be aware of. But we now run this code and we get back our result that has been computed by C faster than PHP. Great. Unfortunately, doing it this way is really slow. Sad panda. Why? Shouldn't doing it in C be a lot faster? Yes, but C code is legitimately way faster to execute than PHP because there's no interpreter involved, it just is raw machine. Cool. But loading up that library on each request, that can be very slow. The larger the library, the slower it is. Also, calling across the boundary between C and PHP is also slow because you have to take the time to translate C variables into PHP variables and back again. Also, running arbitrary C code is a terrible idea because it is very insecure. Who knows what's in that code? You could load it up and start fork bombing your entire server and take down everything. And kids, that's called bad, so don't do that. So how do we solve these problems? Well, remember that preloading we talked about? This is where it gets really fun. By default, FFI works from the command line or in preloaded code. It doesn't work for web requests by default. You can set it to work by default everywhere. You can do that in development, but for the love of God, never do that in production. The default is to just run preload, which means preload and CLI. You can also disable it entirely or just turn off the extension. The preload, however, requires the op cache. The op cache is not enabled on the CLI. So if you have code that's using the preloading on the CLI, you have to then manually enable the op cache. Meh. So let's look at this version. We have to modify the code a bit. We have the same header file, but now we have these two extra define statements. We're going to declare a scope of points, and here we declare the library that we're going to use, points.so. And then in our preload script, we call FFI load on that header file. We don't specify the SO file here, that's specified in the header file. Why? I don't know. And as long as we're here, let's go ahead and precompile that classes.php because, well, why not? So now our preload PHP file, we don't call cdef, we call scope. In preload, we created that FFI object in memory once. And now we can just get a reference to it with FFI scope that grabs it by the same name as we use in the header file. And the rest of the file is exactly the same, no change. Now we can run it by saying, here's our preloader script, and here's our, and enable the op cache on CLI, and here's our script, and that runs and gives us the result we want. If this is a web request, then the op cache is already enabled and the preloader is set in PHP ini. We can take it a step further though, in fact I suggest doing so, and abstract the API. We're now going to give point a toStruct method where we give it an FFI object and it will then map itself to a C-style struct. And we're going to create a point API wrapper that wraps around FFI entirely, creates a single static reference that the library wants. Hey, look on line 5, there's that null assign operator we saw. And then when you compute the distance, it will take those two PHP points, convert them to C, pass that off to the C library, and then return the result. FFI scopes are cheap, so it's okay to reuse them here like this. And we're now hiding all of the FFI bits from the user. So now, this looks like ordinary boring PHP code that just happens to be backed by a C engine. In this case, it is not worth doing. In a much larger case where the algorithm is longer than computing distance between 2 points, it might be worth it. Often not, don't do it by default. You can use Rust as well. If you have a pre-existing library, to use that. If you have to write something yourself, I'd recommend using Rust over C. It's honestly just a better language, it's safer, but you are gonna need to create a header file manually. Okay, deal. Some good examples for this. I have a series on our blog, the platform blog, called Fun with FFI, where I walk through the same material in a lot more detail. I also have these examples that we saw here in both C and Rust ready to deploy on platform as web applications. And Gabriel Couto has a library with a whole bunch of existing C libraries wrapped up into FFI for things like gaming and graphics, which are a much better use case than computing distance. So when should you use FFI? Not all the time. This is useful for really two cases where you have an existing large C library, say machine learning, image processing, things like that. And in the past, you would have had to write an extension for that. Now you don't have to, you can just use FFI. Or if you have a very large custom algorithm that is very big and slow and complicated, then you can, once you've figured out what it is, port that over to Rust, compile that, and load it in. And finally, there are some deprecations and changes you need to be aware of. For one, toString, it can now throw exceptions. In the past, if you tried to throw an exception from toString, PHP would just die. There was no good reason for it. It was just hard to implement. Now it's been implemented, so cool. Odds are it won't affect you, but it might affect some error handling tests. Just be aware of it. Curly braces for strings and arrays are now deprecated. Again, they were deprecated once in the past, but not actually marked as deprecated. And then they were undeprecated. Well, now they're deprecated again, which means lines 3 and 7 here used to work. No one actually did it, but they used to work. Now they don't, or they are deprecated, and in the future will eventually get removed. But yeah, odds are this won't affect you. Left associative ternaries are deprecated. What does that mean? Well, look at this code. What's this going to return? Is it going to check a equals 1 first or a equals 4 first? In any sane language, this would return, would check the first value first and return 1. In PHP, it's interpreted the other way around, which means if you check A, then it prints 4, because PHP is dumb. Every other language in the world does it the other way around, which makes more sense, but PHP. So in 7.4, if you have a nested ternary, then parentheses are now required, and you'll get a deprecation warning if not. In PHP 8, they will be required, and you'll just get a compile error if you don't have them. This gives you a grace period to update. For that matter, though, why are you nesting ternaries? Just don't, and this problem doesn't happen to you. Please don't nest your ternaries. There are much better options. Note that the short ternary doesn't really change because it evaluates the same way either way. So that doesn't change, but the full ternaries, you just don't nest them, just please. Concatenation precedence has changed a little bit. If you have line 2 here, echo string.a plus b. In PHP 7.3, that would interpret the sum.a first, and so you would get a string and then add a string and a number, and the string gets cast to 0, and yeah, that was just weird. So it now means line 8 in 7.4. The internals team, when they made this change, checked the top 1,000 projects on GitHub and found that any code affected by this was actually a bug already, and so we've just fixed the bug for them. So yay. Array key exists with an object is now deprecated. I don't know why you were doing that in the first place. Implode with pieces in the wrong order are now deprecated. So glue must come first, which has been the case for a long time. It's just supported both for backward compatibility reasons. Now it's deprecated. The money format function is deprecated. Use number format for format currency instead, because money format is buggy. Allow URL include is deprecated because it's a security hole and you should never use it ever. Binding a closure to null to try and remove an object from it is deprecated because it does weird things and makes the engine unsafe, because now you have it bound to something that doesn't exist and it gets wonky and weird, so don't do that. If you want to try to do an array access on a non-container, that is, if you put brackets after something like an int or a float or an object that does not implement array access, in the past, you would just get null back and nothing else. Now it'll throw an e-warning and give you null. This was always a bug if you were doing that. Now you're actually told that you have a bug. So if this affects your code, you have a bug. Before we close though, I want to do a quick aside. This is Nikita Popov. He's a longtime PHP core contributor. He's worked on a bunch of RFCs going all the way back. I believe he wrote the original generators support for PHP 5.5. He's been around a long time. He now works full-time at JetBrains. His job at JetBrains is to work on PHP. He was responsible for 7 of the 27 past RFCs in PHP 7.4. That's a quarter of them. A quarter of the new features in PHP 7.4 are because of this person, because this company is paying him to do so. We always talk about, companies need to give back to open source more. This is a company that's doing it. They deserve some applause. So please, say thank you to JetBrains, thank you to Nikita. This is a company that's walking the walk in terms of supporting the communities they work with. So JetBrains and Nikita deserve all appropriate credit. Brief aside there. Okay, that's PHP 7.4. It's kind of awesome. When should you use it? Right now. There are, in the past, there's always a question of when are hosts going to support new versions of PHP. The answer is very quickly these days. This is not the 2000s anymore. This is 2020. There are already over a dozen hosts, dozen and a half hosts that support PHP 7.4 very easily. And of course, Platform is one of them. It's the one I would recommend you use because we make it really easy, obviously. Not that I'm biased or anything. But it's really easy to upgrade to PHP 7.4. If you're on Platform SH, make a new branch, update your app YAML file, and change the 3 to a 4. It's a hard change, I know. Commit that, push it, and activate that branch. We'll spin up a completely new environment based on this Git branch with a complete copy of all of your production data and the code in that branch. Everything will be the exact same as your production site, except now on 7.4. And you can try it out, experiment with it, see if you run into any of those deprecations. If so, fix your code and do whatever you need to do. When you're comfortable with it, your tests all pass, merge, it'll deploy to production, and now your production is on 7.4 with all of the benefits that the new language version brings. You can do this in a day if you have good tests. And that, in a nutshell, is PHP 7.4. Thank you.